Hi, and thanks for joining us. My name is Mike, and I'm an engineer with Yellowbrick Data. Today, I'm going to be going over how to load NetFlow data into the Yellowbrick Data warehouse so that you can analyze extremely large network flows and do it more quickly and more efficiently. If you're not familiar with NetFlow, it's a type of data collection that's used to analyze network traffic. Analyzing large amounts of network traffic has historically been a difficult problem just due to the volume of information that we need to sift through. When it comes to processing NetFlow data, there are a lot of different tool sets available. You've got Flow Tools, Elastaflow, Zeek, but probably one of the best tools for working with NetFlow data is an open source package called Silk. It's distributed by CERT, the Computer Emergency Response Team at Carnegie Mellon. It's a collection of Linux utilities that allow you to collect, store, and analyze traffic. And today I'm going to show you how to export Silk data into the Yellowbrick data warehouse so that you can run analytics on petabyte scale data sets. So let's log into our system and take a look. I have a data file here called data.rw, and it's stored in Silk flow format. If we take a closer look at this file, we can see that it contains about 368,000 records. Now, by the way, the Silk file format is great for storing historical backups of NetFlow data because it makes very efficient use of disk space and the files are searchable. Silk provides you with a set of command line tools that let you search through small collections of flow data and filter out the records that you want to look at. This search function works okay for small collections of data, but if you wanted to analyze, say, 6 months of network traffic and run big analytic queries to build charts and graphs, you need something a little more robust. That's where Yellowbrick comes in. The Yellowbrick data warehouse allows you to search through massive collections in seconds. It's fast, it's incredibly easy to use, and it can handle petabyte scale analytics that other data warehouses can't touch. To get the data into Yellowbrick, we're going to be using the bulk loader. This is probably my favorite Yellowbrick tool. It's a command line Linux app called ybload. When you're working with NetFlow data, it's really important to have a data warehouse that's fast enough to keep up with your production data feeds. You need to be able to see what's going on your network in real time so that you can respond to network events quickly. Optimizing the load process is extremely important, so we've put a lot of engineering effort into making our loader as fast as possible. You can ingest NetFlow data into Yellowbrick at several gigabytes per second. That's tens of millions of flow records per second. And here's how. First, let's log into our Yellowbrick system and take a look at the table that we're going to be loading data into. As you can see, we've got all the standard fields for storing NetFlow data. IP address, source port, destination port, flags, that kind of thing. Now, here's a cool feature. Look at the data types for the source IP and destination IP. Yellowbrick supports IPv4 and IPv6 data types natively and stores them in binary format, which can be scanned much more quickly. It also allows you to do some really cool things with your queries, like you could search for all the addresses within a given subnet. Before we can import our data into Yellowbrick, we need to convert it into a format that our bulk loader can understand, like a CSV file. Silk comes with a great utility called rwcut, which exports Silk flow data in CSV format. And here's what the command looks like. Okay, let's exit the database here. Okay, so this is our rwcut command. We're going to be taking the data.rw file as input and specifying which fields we want to export. Now, notice how the fields in this command are listed in the same order as the columns in the database. This was done on purpose. It's a quick and easy way to do the field mappings for loading data. I've also added a couple of extra formatting options to make it easier to ingest. So now we have a CSV file that we can send directly to the Yellowbrick bulk loader. Okay, so let's start up the loader. The command is ybload-t, and then the table name, and then we feed in our CSV file. And we can see that all 368,000 rows were loaded successfully. Now let's see what it looks like when we load a large data set. I have a directory here with 300 gigabytes of NetFlow data in it. These are all CSV files that were generated by rwcut. We're going to run the ybload command again, but this time we'll add some additional tuning parameters to make it go a little faster. All right, it's starting up right now. And you can see it starts out at about 395 megabytes per second and slowly spins up. Now it's running at 1.4, 1.28 gigabytes a second, and it'll slowly start to spin up as multiple threads come online. You can see here we're loading data at about 19 million rows per second. Now, this is great, but loading data this way is a two-step process. You have to export it to a CSV file and then load the CSV file. But you don't have to do it this way. I separated this out into two steps to make it easier to explain. You can do this in a single step. For example, suppose you want to ingest your live production data feed directly from a SilkFlow receiver. That's no problem at all. You just pipe the output of RWCut directly to YBload. So let's stop this. Okay, so here's what the command looks like. We have our RWCut command piped directly to our YBload command. So we'll hit enter and kick that off. That was a small data set, so let's try a larger one. I'm going to simulate a live data feed by streaming in data from a large SilkFlow file. I have the file right here. It's about 4 gigabytes, and we're going to run the same RWCut command on the larger file. So same command, we're running RWCut and then piping the output to YBload. Now, as we can see, the speed is, it will be slowly ramping up, just like before, but you'll notice it's not going quite as fast here. And this is not an issue with Yellowbrick. The Yellowbrick loader is waiting on the RWCut command to generate the data, and RWCut can only generate data so fast. Yellowbrick can ingest the output from RWCut at line rate, so we can load it as fast as the tool could generate it. But on this particular virtual machine, running a single instance of RWCut, that's about as fast as it could go. Now you can speed this up significantly by ingesting multiple data feeds at once. So what if, instead of one instance of RWCut, we had 16? So that was running at about 32 megabytes per second. Now I have a script here called multi-pipe load. Let's VI that. This script will create 16 instances of RWCut and then pipe the output to a set of named pipes. Once they're all running, we'll execute the YBload command, and YBload will read data from all 16 pipes at the same time. So let's try it out. All right, as you can see, it's running much faster now with all 16 pipes. 375 megs a second, 392 megs a second. So it's running at about 5 million rows per second. That just ran a commit. All right, while this load is running, let's log into our Yellowbrick system and take a look at the load process. Okay, now we're logged into the Yellowbrick System Management Console, and let's go ahead and take a look at our load process. And we can see our load running right here. It's already ingested 2.6 billion rows. We can see here it's ingesting data at about 535 megabytes per second, or roughly 7.2 million rows per second. While this load is running, let's open up a SQL client and see if we can run some queries and maintain good query performance while the load is still going on. I've put together a dashboard in Tableau so that we could run some reports on the live data feed. This dashboard connects to our NetFlow database and summarizes all the traffic based on the destination port. So these are the top 50 protocols that appear most often in the dataset. We've got HTTP, SSH, HTTPS, a whole lot of NetBIOS for some reason. Now under the covers, this is connecting to our Yellowbrick system and running a query. So let's hit F5 to refresh the page, and then we can go analyze the query. All right, wow, that changed a little bit. So let's drill down into that. This is the execution timeline in the Yellowbrick System Management Console, and it shows us everything that's currently running on the Yellowbrick system. We can see the load process here in purple. This is loading data into the NetFlow Silk table, and we can see our Tableau query down here in red. So let's drill down into this query and take a look at what it's doing. This is what the query looks like. We're querying from the NetFlow Silk table. We're doing a group by on the destination port, then joining it with the protocols table to match the port numbers to their associated protocols. That way we can label each row with the correct protocol. Now, if we drill down into this and analyze it, we can see that it did a full table scan of 2 billion rows, did an inner join on 614 million rows, followed by a group by, some aggregate functions, sort, and then return the results to the user. If we look at the statistics tab, we can see this query ran in 8.3 seconds. So we scanned 2 billion rows, did an inner join on 640 million rows, and returned that to the user in 8.3 seconds. And by the way, this is the table that we're loading data into live right now. So we're loading data into this table at 7 million rows per second as we're querying it. So this Tableau dashboard is updating in real time. So if I were to refresh this, you can see the row count. See, now that's 3 billion. And we can update this one as well. All right, and it updated again. And you can see how the distribution of data kind of evolves over time as we load more and more data. Now we've got a whole lot of NetBIOS, a bunch of Zabbix data down here. This is really neat. Zabbix is a network monitoring tool. So to summarize, from our VM here, we were able to load flow data directly from Silk into our Yellowbrick table at more than 500 megabytes per second, or 7 million rows per second, and query it as we're updating it so that you can see the results in real time. And that concludes our demo. If you'd like to know more about how you can use the Yellowbrick Data Warehouse to accelerate your NetFlow analysis project, please contact your local Yellowbrick representative. Thank you for watching.